CIST 2611, Chapter 3, we're going to look at common network topologies and infrastructures. So, some objectives in this chapter is to describe common network topologies and infrastructures and incorporate them into secure network design. The key concepts of this chapter are network devices, physical and logical topologies. We'll discuss Internet Protocol version 4 and version 6, IPv4, IPv6, and also network infrastructures and related security concerns. So first, let's talk about what a computer network is and some common network topologies and infrastructures. Think of a network; it's like a digital community where different devices, like computers, they talk to each other. So the reason we have networks is it helps organizations share information, which helps get work done, manage files, and also increases communication. Networks can also be used as like a storage hub. So you can think of a network as like a digital storage room where everyone keeps their stuff. So it's like having a closet where all of your files are and all the devices can access. And it allows the users, authorized users, to quickly access those data and that resources. Now, networks will use IP version 4 and IP version 6 as the primary methods for addressing, and we will be discussing them in this chapter. So, network topology is like the blueprint or the layout of how your devices and network connect with each other. So, we can discuss about also how computers and peripherals connect, can be discussed with network topology. How are they linked? That is their communication method. How do they connect to each other? The required hardware. So that's the stuff that you actually need for the actual stuff for the digital communications. These are things such as your cables, routers, switches, and also redundancy. That's like a backup plan. Okay, is it if one route goes down between the network, do you have a alternate route? Also, the network diagrams and network maps, these help in understanding those connections and the pathways that exist in your network. That's something that's going to be essential for troubleshooting. Now, we'll talk about a couple different types of network devices. First up is a hub. That's a device that consolidates or collects the wires and connections of other computers and devices. And it collects those individual physical wires and it provides a single connection to the server. Now, a punch down block or a punch panel, it's a type of hub. It's a OSI layer 1, so it's on the physical layer. So this device physically connects the wires together in a single appliance. Now, a smart hub has intelligence built in. This is the most common hub that's on the market. You also sometimes hear this referred to as a concentrator or repeater. Now, historically, the smart hubs have a simple management software that enables network administrators to perform basic commands and also elicit statistics about that network's performance. Now, a repeater is a type of hub that builds a signal that's received through a bit by bit process. So it rebuilds that data and then passes it on. It prevents the data loss by offering the newly reconstructed packets as a stronger signal so it can continue the network to its destination. Now, a switch is a layer 2, a device that's going to use the MAC addresses to differentiate traffic. This is something that's going to be used in a large network, and it does have some ability to perform some error checking and discards any packets with detected errors. A switch can also be used to segment your network through its hardware. Now, a router is a wired or wireless devices that can work on the layer 3 IP addresses. So it's working on the network layer. And this is going to be positioned between different segments of a network, and it allows the connections between those segments and routing traffic from one segment to the destination segment Routers are also used to connect networks or those network segments, and it's to ease the process of that packet transmission. Now, the primary purpose of a router is to direct the traffic towards its destination, and it does that by sending it along the best known, currently available path. Now, a bridge is a layer 2 device, and it's going to act like a smart hub or repeater, but it includes the ability to filter the packets based on the MAC address. Now, bridge also allows connection between two local area networks if those LANs are using the same protocol for communication. And it can also be used to connect the either networks, network segments, or also subnets. Now, a couple types of bridges. A transparent bridge. This is used for LANs that are connected where the individual devices on each LAN are unaware that there's a bridge on the network. Also, a source routing bridge. This is where the routing occurs based on the use of discovery frames that's going to travel the network to determine all the possible paths to the intended destination. And then it's going to select the best path to use. A router is a combination of a bridge and a router. So it performs both the functions of that bridge and a router. And last, gateway. That's a device that connects two networks that use dissimilar protocols for communications. So it's going to be similar to a bridge, and it can function as a bridge, and it takes data packets from one network in a specific protocol and converts those packets to the protocol of the receiving network. So now we're going to look at the difference between the logical and physical topologies. So a physical topology is the way the computer networks are physically connected, whether it's wired or wireless. All computer networks are going to have a physical and logical topologies. The wired topology is the physical wires between the devices that allow that communication. A route we'll talk about is the pathway that the communication packets travel within that wired connection of a network. Now, a logical topology, this is something that's going to be governed more by policy and access than the physical connectivity. And it does focus on the connected computers' access and share data and resources. So it's their primary goal for the logical is how the connected computers access and share data and resources. So now we're going to look at a couple different types of physical topologies. First, we'll look at the bus topology. This is a linear network where the computers are connected on a line. Some characteristics of this network is that it shares a single communication line, and it requires terminators at the end of the physical cables to prevent signal reflection. So this is like a straight road where computers are placed along that route. Data travels along the single road, and terminators act as the stop signs at each end to prevent any issues. Ring topology is a closed cabling scheme where each computer device is connected to two devices, one on each side. So these devices formed a closed loop. It does require a special packets called a token for communications. So in unidirectional rings, the token moves in only one direction. In bidirectional rings, that token can't. There are two connections to each device. So in a ring topology, devices are connected in a circular manner. Data is going to travel in a specific direction using tokens. Each device is connected to two others, and it creates that continuous loop in the ring topology. Next, we'll talk about star topology. This is where independent cables are attached to each device, and all of these are going to be connected to a central hub or switch. Now, these devices, once, like I said, are connected to a central hub or switch. Each device has its own cable, and it forms a star-like structure. It also has performance protection, so disruption in one segment does not affect the entire network. And in the star topology, that central hub or switch, that's going to act as the focal point. Each device is going to be connected to it. This design will enhance the performance protection because it prevents that failure of one segment from affecting the entire network. Now, in mesh topology, devices are interconnected. It's going to form a network where each device has a direct connection to every other device. So this redundancy ensures that if one segment of the network becomes non-functional, communication can still occur through alternative paths. Now, in wireless topology, devices are going to exchange the communication packets through the air, removing the necessity for any physical wiring. So this setup often includes at least one wireless router, and that's used to facilitate the communication between the devices. Now, logical topology plays an important role in managing access and ensuring secure security and also facilitating compliance with legal requirements. It also is something that's going to be important for the separation of duties and access. It limits access to the data and resources to individual devices that require those access. So this is going to help with the principle of least privilege. It's also going to be used to aid in hiding assets as well. Now, there are two main ways to create logical networks. You can do this through subnetting, which is created at the OSI layer 3, which is your network layer. Or you can do it with a VLAN, a virtual local area network. And that is created at the OSI layer 2, the data link layer. Now, choosing between those subnettings or the VLANs, that's going to depend on the network requirements and the objectives of the networks. So subnetting itself, that involves dividing a large network into smaller subnets, and each one is going to have a unique IP address range. The purpose of this is the efficient utilization of IP addresses, network optimization, and also improve security through the segmentation. So an example would this be taking a large network, divided it into smaller subnets for different departments within a company and organization. Now, VLANs are created by logically grouping devices on the same network, regardless of their physical location. So you're creating virtual segments with a VLAN. And this allows network segmentation without the need for physical separation. So it provides a little bit more flexibility and scalability. So the example of this would be grouping devices from various floors or buildings into VLANs so that you would have easier management. So if you had, for example, a human resource department, but they were stationed on each floor, you could set each one of their workstations into a VLAN and put them all in one group. Now, the difference between IP version 4 and IP version 6, the IP version 4, this dominated the internet for 3 decades. It is a connectionless protocol. It will operate on the network layer and is the foundation for the TCP/IP suite. Now, IP version 6 is the successor for IP4. It uses 128-bit addressing, which gives us increased address space. It also has more efficient routing, reduces the management requirements, has a better quality of service, better security. It also is dual stack, so it supports both IP version 4 and IP version 6. And it utilizes tunneling and translation techniques. So the transition from IP version 4 to IP version 6, this was used to address the limitations of IP version 4. In reality, just the fact that we were running out of available IP version 4 addresses. And it also introduced improvements to various aspects of network functionality. So we'll look at the difference between the IP version 4 and the IP version 6 addresses. You'll see the IP version 4 in dotted decimal notations. This is one you may be more familiar with, like the 192.168.12.153 as the example. Where the IP version 6, you'll see it in hexadecimal notation. And I'm not going through that address. You also see the difference in binary between the IP version 4 and IP version 6. So IPsec and IP version 6. IPsec is Internet Protocol Security. This is something that's a mandatory component for IP version 6. And it's used to natively protect the IPsec data. Now, IP version 6, IPsec and IP version 6, it utilizes an authentication header, an encapsulated security payload extension header. It has internet standards that use cryptographic services, security services that provides confidentiality, data origin, authentication, and also data integrity. So IPsec is going to play a very important role in enhancing the security of IP version 6 networks. So it provides a robust mechanism for authentication, encryption, and that data integrity. It wants to make sure that data remains unaltered and intact during transmission, verifies the source of the data, it confirms where it came from, and also ensures that the data remains private and secure from unauthorized access. So now we're going to talk about some different types of network infrastructures and related security concerns. You have a work group. We have a small office, home office, client server, LAN versus WAN, thin client and terminal services, remote control, remote access, and VPN, and also boundary networks. All right, so the small office, home office, these are smaller networks that are commonly found in small businesses, homes, garages, leased spaces, portable buildings. They may use a work group or client server configurations. They're typically more secure than work groups. They often have tools like antivirus software, firewall, and auditing. Client server networks, it's a network architecture where some computers are designated as servers that provide the services, while others are clients that consume those services. The clients are used to connect to the servers to access the resources. So a LAN is a local area network. It's going to be within a single geographical area. With these, the segments are owned and controlled by one organization, and the network owner is responsible for enforcing the security. A wide area network is not limited by geographical boundaries. It can use different types of connections, whether they're leased or external connections and links. They often rely on telecommunication companies, internet, to provide the connections. Now, some security considerations for WANs is that the data is secure if it's encrypted before transmission, and that your security responsibilities, these may involve selecting that telecommunication company and establish a service level agreement with them. Some of these thin clients and terminal services. So in the early models of computing, computing was centralized in a mainframe, and it was controlled through a terminal interface. So those terminals had video screens and keyboards, had no processing, local processing or storage. So all those activities on the mainframe resulted, and the results were displayed on the terminal. With remote control, remote access, and VPNs, the remote controls the ability to use a local computer a system to remotely take over control of another computer over a network connection. Remote access, that allows network resources using a WAN link to connect to a geographically distant network. VPNs, what that does is that it's a virtual private network. It forms a network created over another network connection. So it connects a remote system and a LAN. Boundary networks, these are subnetworks at the edge of a LAN that isolate certain activities. Maybe it be programming, research, but they're out there and they're limited from the private LANs. Now, we're talking about boundary networks and DMZ deployment options. So we'll talk first about the screen subnet using a um, three-homed firewall. So this option involves creating a network segment for a private LAN and another for a DMZ or maybe an extranet. So the three-home firewall that acts as a filtering device in a router. It controls traffic entering these two segments. Now the purpose of this is to enhance security by isolating the DMZ from the private LAN. Now in-tier deployment, this option establishes a series of subnets that are separated by firewalls. The DMZ acts as a buffer between the internet and the private LAN. And the N in the in-tier, that represents a variable that it's a different number of tiers that are built into the network, and it allows scalability. So in this chapter, we've discussed different types of network devices such as hubs, switches, routers, bridges, gateways. We discussed the difference between physical topology, which is the physical arrangement of network elements, and logical topology, that says how those connected computers access and share data, and that is often governed by policies. We've talked about the difference between IP version 6 and IP version 4, and also networks, infrastructure, and security, such as small office, home office, client server networks, thin clients, boundary networks, and LAN versus WANs.